So hey guys, welcome back to the channel. This is your physics buddy. In the last classes, we were talking about forces and motion, that is unit 5. This is going to be another lesson in which we will be discussing different problems based on Newton's second law of motion. This is an assignment solving class, so make sure you solve each and every question along with me. Apart from this, if you are new to the channel, we have already covered different units from honors physics course. You can check it out, links are in the description. And the most important part here is whenever we are learning something new, it takes time, so you have to give time in order to understand something new. Just give 10 minutes to each of the video and you'll understand that how important these videos are for your grade scoring. So let's do this. Make sure you write each and everything. Let's get started.
So now, as I said, we'll start with question number 7, problem 7. So problem 7 says elevator acceleration, that is the topic. So 70 kg passenger stands on the scale in an elevator. The scale reaches 500 newtons. So what does it mean? It means there is an elevator and on the floor of the elevator there is a weighing scale. The person who is standing on this weighing scale finds that weighing scale is showing his weight as 500 newtons. It means the weighing scale is showing normal reaction, that to in upward direction. It is of 500 newtons and its mass is given as 70 kgs. Determine the magnitude and direction of elevator's acceleration. First of all, we have to determine the magnitude and direction of elevator's acceleration. So how can we do so? So in order to do so, one thing. First, it is going to be experiencing some mg in the downward direction. So that mg is going to be 700 newtons. I'm taking g as 10, so it is going to be 700 newtons. Now just think about it. As you can see here that the normal is 500 whereas the mg is 700. So we can assume that it is going in downward direction with some acceleration a. So according to second law of motion, F net external is going to be equals to ma. What is the F net external here? What is the net force acting in the system here? It should be 700 minus 500.
Yeah.
Which is equals to 70 times a. So here it is going to be 200 by 70. That is a. So a is going to be 2.60 means 56. That is 8.5 meters per second square. So this is going to be the acceleration of the lift. And as it is positive, this means the direction which we have considered it is correct.
Hmm.
The second question says if the elevator cable suddenly snapped, what would be the scale reads? If the cable which is connected to the whole elevator just snapped, so what happened to the normal reaction? This is what we have to answer. In order to understand this, when the whole elevator's cable snapped, it will start moving with some acceleration in the downward direction, which is equals to g. So if the acceleration becomes equals to g, this becomes the case of free fall. So lift as well as the person inside lift, they both are going to perform free fall, and because of that, the normal reaction becomes 0. Thus that lift is moving downward with some acceleration which is supposed to be g, and in that case, lift will not read, or you can say the weighing scale will not be able to read what is the weight of the person because it is going under the action of gravity. So that is the thing that is being asked in this particular problem. Understand?
Yeah.
Question number 8. Three connected vertical masses. So there are three masses, 1 kg, 2 kg, 3 kg, hang vertically connected by two light strings. M1 is attached to the ceiling. So this is how the object or the system must be there. This is going to be my M1 attached to the ceiling. M2 hangs from M1. So M2 must be like that. And M3 hangs from M2. The last one must be M3. We have given the mass. M1 is 1 kg. M2 is 2 kg. M3 is 3 kg. Find the tension in the string connecting between M1 and M2 and tension in the string connecting between M2 and M3. Now this is the most simple problem. What you have to do is you have to mention all the forces acting on the system, or you can say you just need to draw the FBD. So what is the best thing you can do here is, first of all, mark the tension. So question says that there is nothing like at which tension is T1 and T2. We can assume that here there must be some tension T1 acting between M2 and M3. There must be some T2 tension acting between M1 and M2. Always remember tension acts in pair. So at both the ends from where the masses are joined, they must be acting. Then there is an mg acting in the downward direction for all the masses, like that. So now let us try to see the forces or the net forces. Before actually moving into it, just tell me, is this system moving? Can you say that this system is moving?
Um, yeah.
How? In which direction you'll find it in motion?
Downward.
The whole system is connected to the ceiling with the strings, and these strings are inextensible. They won't move. So how can you say that the system is moving? This system is in state of equilibrium. You can say that.
Okay. Okay.
System must be at rest. This is what you have to remember. So net force acting on all objects is going to be 0. As the system is not in motion, so net force must be 0. Now let us consider M3. So M3 is experiencing tension in upward direction and Mg in downward direction. So this implies T1 must be equals to M3G. M3 is 3 kg, G is 10, so this must be 30 Newton. So tension between M2 and M3 is going to be 30 Newton. Similarly, this is my M2. In the upward direction, there's an tension acting T2. In the downward direction, it is acting T1. Also, along with T1, there is M2G. You can see that. So now in this case, also F net is going to be 0. But what about F net? What we can say about F net? As the whole system is at rest, M2G plus T1 minus T2 must be equals to 0. So T2 must be equals to M2G plus T1. What is M2? 2. What is G? 10. What is T1? 30. So T2 is going to be 30 newtons. 50 newtons. This is how you're supposed to find out the forces acting in a given system. You don't actually have to see how forces are acting, but always remember the basic thing. If the system is at rest, net force is going to be 0. Let me just give you a quick revision on that. So F net will decide the fate of the motion. If F net is 0, then the system is supposed to be experiencing some balanced forces. If the system is experiencing some balanced forces, it means system might be at rest or moving with constant velocity. Now this F net 0 doesn't mean that net force is going to be 0 in one particular direction. We will say F net in x-axis is equals to in y-axis and is equals to 0. This is the case of balanced forces. System might be at rest or might be moving with a constant velocity, but it will not accelerating. If F net is 0, we can say dp by dt is 0, and this means acceleration is 0. But velocity can be constant. So this is one such case that you keep in mind.
Mm.
Now, next question. Question number 9. Question number 9 says two blocks pushed together. A constant horizontal force of 120 newtons push two blocks M1 and M2 that are connected with each other, that are in contact with each other across the frictionless horizontal floors. Every time, whenever you are looking at any problem, first of all, you have to draw that problem.
Mhm.
So they are in contact like that, and they are experiencing some force in the horizontal direction, that to 120 newtons. So this is going to be 120 newtons. That is the external force experienced by these objects. Now, pushes two blocks M1 and M2 that are in contact. What is that is in contact with each other across the frictional horizontal? Calculate the acceleration of the system. Determine the magnitude of contact force that M1 exerts on M2. So let me assume this is my M1, this is my M2, and M1 is given as 4 kgs, M2 is given as 6 kgs. We have to find out the acceleration first of all. So it's pretty simple now. Again, according to Newton's second law, F net external must be equals to mg. Ma, where m is supposed to be the total mass. The net force acting here is 120 newtons. Total mass is supposed to be 4 plus 6 into A. So A is going to be 120 by 10. That is A is going to be 12 meters per second square. So finding A is the most easy task you can do in any question. But yeah,
Yes.
next problem is finding the reaction force or the contact force between A and B. Now let us try to understand and look at the diagram by considering some space between them. So this is going with A, this is going with A. If we exert a force F from external direction or outside, so this will definitely try to push that block away.
Yeah.
So there must be some normal reaction on this surface, and because of that also, it will apply some normal reaction in this direction. So we have to talk about the contact force between M1 and M2. So I can just consider this as my system, like this as my system, and try to solve the equation for it. So as the system is moving in forward direction, so if I apply the net force equation in horizontal direction, so F minus N must be equal to M1A, because this is something I have written for mass M1. Mass M1 must be experiencing two forces. One is contact force and another is external force, and they both are acting in opposite directions.
Yeah.
So F must be equals to 4 into 12. That is, it must be equals to 120 minus 48, or you can say 52, 62, 72 newtons. So this is a normal force that is acting between block A and block B.
Mm.
All right, then let's move to the section third, that is inclined planes, frictionless. That is the important part. There is no friction. So block on simple incline. So block on simple incline means that there must be some incline plane like that, and there must be some angle of the plane. The question says that 20 kg block rests on a frictionless slab inclined at 40 degrees to the horizontal. That's 20 kg block. Calculate the magnitude of force exerted to hold the block motionless. We have to find the force so that object remains stationary. Now that is interesting. Remains stationary. So what do you can think about this problem? Think and tell me.
Mm.
Like what force is required to make the object stationary? That is what we have to think. And if the
So
block is released, what is the acceleration from the down the ramp?
there's
All right.
normal
So
force that makes it slide, right?
there is which force which makes it slide?
Normal force.
Not normal. Normal will not make it slide.
I mean, I'll make it push it upward, like if an object is being pushed down by gravity, and then there's a normal force pushing back up, right?
Mm. You cannot say that because normal force is only there because there was a gravity. Normal is just a reaction to the gravity. If there is
Oh,
a gravity, the main consequence of the forces we will observe on the object is that it is moving under the gravity. Object never move under the normal. Remember this.
okay.
So here, what we can say is that there must be some mg acting in the downward direction. So let's start by simply explaining its FBD. So there must be some force acting in downward direction, which is supposed to be called mg. Apart from this, it must be experiencing some normal in this direction. So which force is actually responsible for the motion of the object in the downward direction? It must be
Gravity.
some component of mg.
Oh,
So this is 40 degree. This must be 40 degree. So the force which is pulling this object downward direction, it is going to be the component of mg, which is represented by mg sine theta. Whereas in this direction, which is against the normal, the component of mg acts, it's mg cos theta. So here what you need to understand is that mg cos theta is the component which is opposite to the normal, and mg sin theta is the component of force which is actually pushing, or you can say the pulling the whole object of 20 kg mass in downward direction.
okay.
So what force is actually required to place that object motionless? That same amount of force which is mg sin theta. The force which we needed is mg sin theta. If we are able to apply the mg sin theta magnitude of force in the upward direction, we'll be able to have object at rest. So just put the values and you'll get the formula, you'll get the force. But what is the force needed?
Mm. F.
So just put the values and get the answer.
Okay. Okay, calculate.
What you got? Tell me.
It's on my calculator, so let me just use my computer. I got 146.04. Or it should be centigrades, right?
Should be
Calculation
40
should be,
degrees.
yeah, but should the calculator be centigrades, not radians?
Yeah. So you got around 140.
Oh no, it was set in radians. Let me just do. Got 125.9.
That much force must be acting in the downward direction. So we have to apply the same magnitude of force in the upward direction to keep that object at rest. Similarly, if the force is not acting, if this force, the external force is not there, so mg sin theta is pulling the whole object in the downward direction. So the question is with what acceleration the object will go down. So in order to find out the acceleration with which the object will move down, what we can do here is we can apply again the same relation if net in the downward direction must be equals to ma. So acceleration is going to be F over m. F is 125.9, mass is given as 20. You can solve and get the value of acceleration. Do it and tell me.
6.29.
All right. So this is a way to do this kind of problem. 6.29 meters per second square. Remember the concept, what we are doing exactly here. And most
Yeah.
of the questions, almost in 80% of questions we are doing from this particular unit, you'll be applying F net is equals to ma. So make sure you know the application part very well. Let's move to question number 12. The problem 12 says that block MA sits on a frictionless 25-degree incline and is connected by a string over a pulley to a hanging mass MB. Determine the direction of system's acceleration up or down incline, magnitude of acceleration. Now again, the most important part here is to understand the diagram. So our system must look like that. Incline is 25-degree and the masses which are connected, they must be connected like that. So the question is, what is the acceleration? So it is 7 kgs and it is 3 kgs. So now just think and tell me in which direction the whole system will move, in the direction of 3 kg or in the direction of 7 kg?
Direction of 7 kg.
Yeah, but before that, you have to actually check whether it is going to move in the direction of 7 kg or in the direction of 3 kg. How we can check this out? We can check this out by actually looking at the forces which are acting in their respective directions. So for the 3 kg mass, the force which is acting in the respective direction is 3 into 10, 9.8. Whereas in this case, it is going to be mg sine 25, which is approximately 7 times 9.8 times sine 25. So just find out the value of both the forces and tell me which one is more.
Um, Actually, I'm getting 3 kgs more.
Yeah, that's the case. So what is the force? Tell me.
This one is 28.9.
And
And
this one?
that's 29.4.
Yeah, 29.4. So as you can see here, the force acting through 3 kg is more. So what will happen here is the system will move along 3 kg mass.
This is because of the angle they're both
Yes,
placed.
yes.
Gravity
That
is able.
because of the angle, the component of gravity has reduced the force acting drastically. The
Okay.
system will move along the 3 kg mass. That's towards right. So now we again are going to apply F net equation. As you know, F net external is equals to product of mass and acceleration. The net force acting here is going to be 29.4 minus 28.9. That too equals to 10 times A because mass you have to substitute as total mass of the system. The acceleration is going to be 0.5 divided by 10, that is 0.05 meters per second square. Towards right. You can mention the direction as well here. So this is going to be the answer.
Okay.
Questions are not that much difficult. All you have to do is just focus on the basics. Remember the forces and their directions. If you're able to understand it, you can go with it, any problem. So next question is saying that there is a 10 kg box is pulled up a frictionless 30-degree incline by a constant force Fb parallel to the incline. So there must be some incline, there must be some object, and we are pulling that object with some force Fp because it is parallel to the incline. The incline is supposed to be 30 degrees. Object is supposed to be of 10 kg mass. If the box accelerate up at the incline 1 meter per second square, so we have given acceleration here, which is supposed to be 1 meter per second square in the upward direction, in the direction of parallel force. Find the magnitude of the pulling force Fp. Now again, a very simple problem. Just look at the forces acting on the block. In the upward direction, there is Fp acting, whereas in the downward direction, which force is going to act? mg sine 30. And the
Yep.
whole system is moving upward with some acceleration. So we know from equations, second law of motion, F net is equals to ma. Net force is going to be Fp minus mg sine theta. Where total mass of the system is 10 kg and acceleration is given as 1. So Fp is going to be 10 plus mg sine 30, which is 10 into 9.8 into 1.1 by 2. So it is going to be 10 plus 49, that is 59 newtons. So this is going to be the pulling force, which is pulling the whole object upward, or parallel force, which is pulling the whole object upward. And because of this force, object is in, we can say, 1 meter per second square of acceleration. So these questions are pretty simple. What you have to do is you have to understand that how objects are moving. If you are able to see that how objects are moving, you'll be easily able to solve these problems. I hope these questions make sense.
Yes.
Let's move to the next problem, question number 14. So 14th question says, a 5 kg block sits on a frictionless 20-degree incline. A horizontal force Fh 40 newtons pushes against the block. Calculate the normal force again acting on the block. Calculate the acceleration of the system along the incline. So there is a horizontal force pushes against the block. Like, what does it mean? So there was a incline, and that incline is of 20 degree. There is a block of some mass, 5 kg. Now what happens here is we are applying some external force in the horizontal direction against the block. The force must be acting in this way, and the magnitude of this force is 40 newtons. So question is, we have to calculate the normal reaction. How can we do so? Just look at the FBD carefully. So here normal must be acting this way. There is an external horizontal force of 40 newton this way. There must be some mg acting in this direction, and against mg there is a component which should be mg cos theta acting in this direction. So mg cos theta, this f must have two components, one along the direction of horizontal force, not horizontal, but one along the direction of mg cos theta. If this is 20 degree, this angle is again going to be 20 degree. So this is going to be 40 cos 20, and whereas this is going to be 40 sine 20. Whereas here it acting mg sine 40, not 40, 20 degrees.
Yeah.
What you need to understand here is that the force is whichever it is acting, you need to see the direction of the force. If you're able to identify the direction of force acting in this direction, so you'll be able to solve it. Now, in the horizontal direction, these are the balance forces, whereas in the vertical direction, normal is going to be equals to sum of 40 sine 20 plus mg cos 20. So normal must be equals to 40 sine 20 plus mg cos 20. As the whole system needs to be addressed, so we can apply these things. So just put the values and let me know the answer. This is going to be the normal force.
So 59.7.
All right. Now we have to look at the motion along the inclined direction. So because of these two forces acting in upward and downward direction, there must be some acceleration of the system, acceleration of the block. How can we find that acceleration? By actually finding out the net force. So in order to find out the net force, just find out the values of these two forces, mg sine 20 and 40 cos 20. Just look at these two forces and tell me which force is bigger and in which direction the whole system will move.
Mm-hmm. Mm-hmm. 40.
Mg sine 20 and 40 cos 20, which is more?
Let's see. I calculate all at once. So 40 is 13.6. And 5 times. So what do you say? The mg cosine 20 is more. So mg sine 20 is 13.6. And 40
And
close 46.04.
how much? 46.04? No, it's not possible.
No, oh, whoops.
It cannot be more than 40.
37.5 or 37.6.
Okay. 37.6. So we can see here the object is going to move in the upward direction. So the net force is going to be 37.6 minus 13.6, and it is equals to 5 times A. So A is going to be 24 by 5, that is 4.8 meters per second square upward or up the incline. So this is how you're supposed to find out the acceleration of the system.
Okay.
You just have to look at the diagram. You just have to try to draw the diagram as perfectly as you can draw. You need to understand how the forces must be acting and simply apply F is equals to ma. There is no more or anything else you are going to apply here.
Okay.
So last question of this particular section, problem 15th. The question says system of two incline. So there are two inclines. So M1 and M2 are connected by a string or a pulley and placed on the two opposite frictionless inclines. M1 on 30-degree incline, M2 on 50-degree incline. So how does it look? Something like that must be there. So it is going to be 30-degree. It is going to be 50-degree as per the question. So 30-degree incline has M1 mass, so I can consider M1 here. And 50-degree incline has mass M2, I can consider M2 here. There must be some pulley which is connecting these two masses like that. So the question is, determine which way the system will accelerate. So which way system is going to accelerate will depend upon the force that both the masses are going to experience. And how can we find that? By simply understanding which force is pulling them downward or down the incline. Here it is going to be M2g sine 50. Here it is going to be M1g sine 30. So find out the value of both the forces and tell me which one is more. So whichever is more in magnitude, in that direction the system will accelerate. But first of all, we have to find out the direction of acceleration by finding out the magnitude of these two forces. So find out and tell me which one is bigger, M1g sine 30 or M2g sine 50.
60 for M2G sine 50.
60 exact.
Or 60.05.
And what about this one?
Got 24.5.
So if you try to find out the net force, it is equals to MA.
Maybe.
Net force is going to be 60.05 minus 24.5 and is equals to the sum of the two forces, that is sum of the two masses, that is 13A. So A is going to be what? 25.45, 35.4, 35.45 over 13. So now you can have the acceleration easily. Solve it and get the answer.
Okay. That's 2.73.
So this is the way of solving these kind of problems.